Hey guys, so I just want to welcome you to Wednesday's class, and this is our last class before we have a quiz on Friday. Remember that we are having a quiz day on Friday, so that's the day that we're starting to transition over, where things are due on Friday, and any quizzes and tests are given. And this is kind of a transition week because of people already having it assigned work, before we found that out. So this week, I know you had like a little test in well, not a little, but a test in Miss Kara's class. And that was not during the Friday window, but I think it is due by Friday. So do keep that in mind. I want to give a shout out, a happy birthday to Sophia Ickes. Today's her birthday. Happy birthday, Sophia. And I'm glad you guys are all here. I miss you. I know you're only virtually here, but we've got 50 of you here, and I'm proud about that. And so thank you for showing up. So let's get right down to it, because there's a lot to learn today. So I'm going to just admit a couple people in that are just showing up, but thank you so much for coming today, and happy birthday, Sophia. All right, so on our agenda today, we're going to do a little EDSB check-in and I'm going to show you, the important part of that is showing you where your study guide is. So if you have your study guide out and ready, it was posted on EDSB this morning, and it is attached to the EDSB post, but you can also just pull it up on your computer or on your device, just attached in a window. You do not need to have it printed right now. I would definitely, if you have a printer, I would definitely do that for your quiz. But if you don't have a printer, don't stress. You can just pull it up in a window. It's a PDF, and you can go ahead and reference it there. Oh, also, it's Martin's birthday too. So I want to say happy birthday to Martin, and thank you guys for shouting that out. Martin, you got friends that are telling me it's your birthday, so you got a lot of people watching out for you. So happy birthday, guys, and hopefully I'm not missing anyone there. We are going to review a little bit from 5th grade, which is about line plots and dot plots. And then we're going to talk about the shape of data, the shape of the distribution of data. And then we're going to do some guided practice. And then I'm going to kind of remind you about our new Friday routine that I just talked about right when we started class. Okay. So right now, first off, we're going to go ahead to EDSB. So just give me a second here to get on there. Got to get out of there. Okay. So EDSB, hopefully you guys are seeing this. Yeah, I think you are. Okay, so this is today's post. This is what we're going to learn, the materials needed. I went ahead and I highlighted what was really, really, really important, but you do still need to read this, read the whole thing, not just the yellow parts. But we do have the study guide here, and that is attached right down here. I wrote it in bold, study guide, and then to the right of it is the slideshow. And that's, some people say they still see the PowerPoint. That's weird. Just give it a second, maybe. Hopefully that's better. You guys see EDSB? Give me a thumbs up. I think what's happening is the internet's a little slow right now. And so my internet is having a little spotty issue right now. Hopefully that will resolve itself. Let me check that out. I've got, just give it a second. I think I'm going to have to refresh the page or something. Just a black page. Oh no, I'm a black page. Oh, yay, we can see now. Okay, I think it's starting to work. It's just taking some time. My internet is starting a revolution against me since I'm becoming a YouTuber. It does not want this to happen. Okay, so hopefully that's up now. Give it a little bit of time to process. We all need that. I know if I glitch right now, guys, it's because of the internet right here, but hopefully it will come through. I'll try to go slow because of the glitchiness. But anyway, the very important thing is your study guide, and that would be found right here. It's a PDF. If you click on it, it pulls up this. This is the PDF, and this is something that you can use on your quiz. So this is a lot of what we're going to be going over today, but then also stuff we've already learned. So that's something that I just kind of compiled it all there for you so that it would be easy for you to go ahead and use that on your quiz. And you could use anything else that you've seen in my PowerPoints or anything else that you've found that helps you. And then the slideshow that we're going to be using today is right here. Okie dokie. And now we have IXL practice today. This is different than the one from the other day. This is on interpreting charts and graphs to find mode. And this can be found at shortcut AMK. So you can go to IXL, you could type in AMK in the search and it will pop right up. Someone just asked, do we have to print the study guide? No, you do not. I said if you have printer ink, go for it. But if you don't, just pull it up as a PDF. It's totally just for your own use. I'm not there checking it out or anything. So don't worry if you can't print it. I'm trying to go slow because I know the internet's kind of being ridiculous right now. All right, so IXL, you only need to get to 70. This is for practicing purposes. This is not for a grade, but I'm recommending you have that done by 11 o'clock on Friday for two reasons. Number one reason I want you to have it done by Friday at 11 is because that's when you're going to have everything done by starting next week. So I want you to kind of get used to that. And number two, because you're having a quiz on Friday at 11. So I want you to have that practice in before the quiz. And some of the things that are on today's IXL might not be on the quiz, but a lot of it is. I also went ahead and posted a bunch of resources here, and this is updated with the thing that we're learning about today, which is the shape of data distribution. Click on that. You'll get to a Khan Academy video that will teach you about data distribution and go over it in maybe a little different way than I am. So that might help you as well. Later on, you can kind of watch these videos to study for your quiz. All right, so let's kind of get back to our slideshow and then we will be good. So let's go back here. So on your own time, again, what am I asking you to do? I'm asking you to do IXL, and I'm asking you to review the study guide to prepare for Friday's quiz. So just give it a second if it's still laggy, guys, but it will come back to the slideshow. It's just, like I said, starting a revolution against me. Hopefully that's up now. Give me a thumbs up if you see my slideshow. Okay, good. I see mostly thumbs up, some thumbs down. So, but they're mostly up. So hopefully it will reach you in just a second. I don't know why it's laggy today. So review the study guide, do IXL up to 70. Those are the two things. Now, the other thing is, if you have questions, guys, come to my office hours. A lot of things get done there where I wish, oh man, I wish there were more kids in here right now, because I'll go over the skill again, or you can ask any questions you want, or we might work through a couple of problems. We even the other day did a little bit of the IXL skills, even though they're different for every computer, you know, they pop up randomly. I can still help you practice. All right, so come visit me at between 2 to 3, and the code is right there. Today's focus is to find out, how do we describe shapes of data distribution in plots and graphs? And we're going to talk about several different types of plots and graphs today. My tip for you is to have that study guide at the ready for your Friday quiz, and just this whole week, anytime we're talking about statistics, it's kind of like your little go-to. A lot of vocab, it goes into this chapter, so you're going to want to see that. A lot of visuals. So have that at the ready, even if it's just in a, you know, pulled up as a PDF, okay? Again, I'm going to go ahead and review with you that there are two types of measures we're talking about. We're talking about measures of central tendency. Those summarize a data set to talk about the center of the data. Measures of variation or spread represent how values differ from each other. So how are they spread out? And that would include range and interquartile range, and something called mean absolute deviation as well. But measures of spread talk about, the difference, how they range, that kind of thing. We're going to review, because I don't like to jump right in. I just want to review a little bit about what we talked about last time. And if this looks completely new to you, that means you may not have showed up to last lesson. So make sure that you go back and you've watched all of the lessons on YouTube if you missed any, because you're going to miss a ton of information. Last time we learned that no matter the size of the whiskers and no matter the size of the box parts, each part of a box plot is worth 25%, because each part of the box plot shows a quartile, or a quarter of the numbers in a data set. So no matter the size of the whisker, if it's a really long whisker, a really short whisker, it's still showing 1/4 of the numbers. So it's still showing 25% of the numbers. And if you did the skill on IXL that was from Monday, then you did practice on that. And so you basically are counting by 25 for every part of the box. Okay, so it's like 25, 50, 75, 100. And that's how you know, if something, like what percent of the data is 9 or less. Well, then you look for the number 9, and then you see how many pieces of the box plot are there. If there's 2 pieces, it would be 25 and then 50%. So 2 pieces, 2 25s. Okay, so it'd be 50%. If there's 3 pieces of the box and whisker plot, then it would be 25, 50, 75, and you'd get up to 75% of the data. So go ahead and make sure that you are practicing that on IXL if you have not already. So that's now 2 skills for this week of IXL practice to get you ready for the quiz. All right, and here is something else we learned last time, which is interquartile range, which is a measure of variability. You need to know that that is not a measure of center, it's a measure of variability. And it focuses on the actual box itself. It focuses on the difference between quartile 3 and quartile 1. So basically, it's the length of the box. Okay, if you measure the length of the box and you count 1, 2, 3, 4, 5, 6, 7. Okay, so this is 7 numbers long, so that means the interquartile range is 7. Or you could simply just subtract Q3 minus Q1 to get your interquartile range. Okay, so you need to know what interquartile range is. So let's jump into what we're talking about today, because there is a lot of vocabulary and there is a lot of different little pieces to this, but I promise you it's really not as hard as all these vocab words might lead you to believe. It's not as hard as you might think. It's just lots of little vocabs. Now the vocab is kind of good because it references words that you probably already know the meaning of in other ways, just not in math. And you can use that knowledge to kind of help you understand what it means in math. All right, so line plots and dot plots. These should have been introduced to you in 5th grade. Even before that, they may have been introduced. Even as low as like 1st grade, you might have had picture representations of these. Basically, it's counting up the frequency of repeated numbers in a data set. So you would use these in data sets that have a lot of repeated numbers, like maybe survey results. Like it could be like how many siblings you have or how many hours you're studying. Okay, results that are going to have a lot of the same numbers in them. So these are line plots and dot plots. Now, if they have X's like this one on the right, then we call it a line plot. If they have dots like these on the left, then we call it a dot plot. They are the same thing. Okay, it's just X's versus dots. So if you get them mixed up and you call a line plot a dot plot or a dot plot a line plot, it is not the end of the world. They are the same things, okay? basically it's just a matter of preference. So it's just another way of displaying data. So one thing that I really want to point out to you, and this question is going to reference a question on the quiz, okay? And that is, what they want to do is they want to be sneaky with you, and they want to see if you know your stuff. And one question that will a lot of times come along with these is that how many people were surveyed, or how many answers were there, or how many numbers are there in the data set. Well, you're just counting your X's or your dots, okay? And that tells you. So over here it says number of children per family. The answers are only from 1 to 5. Those are the answers that people gave, 1, 2, 3, or 5. Excuse me, 1, 2, 3, 4, or 5. However, the number of people that answered would be the number of X's on here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they surveyed 10 people. So you would count up the total number of dots and X's, and that would tell you how many numbers are in the data set, or how many, people answered that question. So that is definitely one of the things that pops up a lot. Someone said they can't see the slide. It might be that the internet is just being funky. Hopefully you can see it now. Someone else asked, is this the study guide? This is not the study guide. This is my presentation. Your study guide is attached to the journal post for today, and it's also clickable inside this PowerPoint. So if you download the PowerPoint, then you'll be able to click right on my yellow slide here and get to the study guide that you need to get to. And just be patient, guys. If some of you are having a little glitchiness on your end, just be patient. It will work itself out in a minute. We have 70 people here today, and my internet is not liking that. So hopefully it won't be so laggy. If you see a black screen, that's why. All right, so hopefully it will reshare my share, and I keep re-clicking it just to kind of throw it out there at you guys. All right, so line plots and dot plots. So here is an example. It says students in one class recorded how many first cousins each student had. Here are the results. So in the table here, they're just unordered data. This is just all the results. Maybe the first person they answered all the way down to, what is this? 1, 2, 3, 4, 5, 6, 7. This is 21 people that answered. Okay, 3 times 7. So 21 people answered this question. So there should be 21 X's on my line plot. Always double check that. If you're making a line plot or a dot plot, make sure that you did not forget one, because it's really easy to forget a dot or forget an X. So make sure you count them. Okay, but basically all you're doing is drawing a number line. Now, if I had to do this from the get-go, like from scratch, I would look at the numbers that are the answers to the questions, and I would say, okay, these range from the number 1 to the number 7. So I know I need a number line from 1 to 7. And that's how you kind of decide how you're going to draw your number line. Then when you draw your number line, you decide, do I want dots or X's? And then you go ahead and start placing them. Now, the really important part of this is that you place them so that they're lined up. Okay, I used to do a really cool project with this chapter, and unfortunately we didn't get to do it, but it's where their kids were making posters in class about their favorite marine animal. And so they did a lot of drawing their own plots. And this happened where some kids would draw really little X's on one number, but then really big X's on other numbers. And if they're not uniform, then the person who's looking at the line plot can't quite decipher which number has the most, okay? So they have to be a uniform amount size, like the same size and all lined up like this, okay? So we're gonna talk about how we interpret these line plots and dot plots in just a second, but I do wanna talk about creating them, which is something from 5th grade or grades earlier. You can go ahead and hit Control-click when you download this PowerPoint, and it will send you to an activity. So if you really want to practice more, you can download the PowerPoint and click on this activity, and it will send you here. So let me make sure that you're seeing what I see. So let me go ahead and get to it. It will send you to this Google Slides presentation about creating line plots. And so the data set is over here on the left, 3, 7, 5, 7, 5, 6, 8, 3, 5. And then the X's are over here on the right, and you're just dragging and dropping. I know you guys love dragging and dropping after my drag and drop activity. But go ahead, and there's 1, 3, there's another 7. So I'm going to do this in order so I don't forget. Okay, there's a 5, and I'm just dragging and dropping these and trying to make sure that they're lined up somewhat. Another 7. You're just, if there's more than one number, you stack it right above it. Okay, another 5, a 6. Now, what I was talking about is what if you have like if someone put a 6 right there. If you put a 6 right there, it's going to be hard for someone to read this because it's going to look like this is the same amount, 5, 6, and 7, when it's not. So you need to make sure that the first level is lined up like almost like a 1-story building and then a 2-story building, you know, kind of like that, like their stories. So 6, then 1, 8, then a 3, another 3 stacked up, and then another 5. So then you double check by counting. So there should be 9 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. And see, there's even, I would even correct it a little bit so that they're nice and lined up. All right. So that shows you what a line plot looks like. Now, from there, you guys can do a lot with these. Okay. They might even ask you, what's the mean of this data set? Okay. So you might even have to figure out the mean just by looking at the line plot. And to do that, you're just going to add up the numbers 3 plus 3 plus 5 plus 5 plus 5 plus 6 plus 7 plus 7 plus 8. You add them up, you divide by 9 because there's 9 numbers to get the mean. And in fact, I'll go ahead and do that now. Let me just pull up my calculator here, my trusty calculator. So I'm going to say 6 plus 15 plus 6 plus 14 plus 8. I simplified it a little. 49 divided by 9 equals 5.4 repeating. So I'm going to go ahead and just round that to 5.4. So the mean is 5.4. And then the median. Now, the way you find the median with these is you could do 2 things. You could either just write out the numbers from least to greatest, okay, and find the median that way. Or you could look at these X's and say, okay, there's 9 X's. So I need to find the middle. I need to get to the to the 5th X. Okay, so that there's 4 on the left and 4 on the right and 1 in the middle. Okay, so 1, 2, 3, 4, 5. And then I'm just to double check, I'm going to do this 1, 2, 3, 4, 5. So either way, you're going to end up right here at 5. So your median is 5. This is optional, this activity, guys. I'm just doing it to model it to you. And this is something you can do that's included in the PowerPoint, but you definitely do not need to. Okay, this is just extra and just a little fun way to show you how to make a line plot. And then the mode would be the number that occurs the most. And that, you guessed it, that's going to be 5. Okay, because that has the highest stacked up X's, and we call that something, we call that a peak. Not a William Peak, a peak. Okay, that was a shout out to Will Peak. But yes, that is the peak of your plot. Okay, so that is also the mode. All right, so we can decipher these line plots and come up with a lot of different answers to questions. This is an activity that's actually self-checking if you want to do it. I do believe the answers are included. I might be, maybe they might not be. I don't know. I think they are. But that's something that you can do if you want to. Again, it is completely optional. So let's go back to our PowerPoint and just give it a second to transfer back. Again, you can find that activity right here where it says click here, and you can do that there. We got to move on though, because we got a lot to learn, guys. So here's an example of creating a line and dot plot, and I'm going to make a dot plot here. And let me get my drawing tools out. I'm going to go ahead with a rose gold pen today, guys. I'm getting fancy. Okay, and I'm going to go ahead and put a dot for every number in this data set. This is 5th graders kept a record of how many times they called one of their first cousins on the phone, and these are the results. So every time I see a number, I'm going to go ahead and put a dot. So 2. You know what I'm going to do? I'm going to call on someone to read this list out to me. So raise your hand if you're okay with reading this list out to me. I'm going to go ahead and call on Miss Jovi Prosper. Hey, Jovi.
Hello.
Hey, thank you so much for your help, because I know that me watching this and keep looking back at that data set, something's gonna go wrong. So if you could just read these numbers out to me and wait for me to write.
Okay.
Yeah, go for it.
2.
Okay. Oh boy, wait 1 second, Jovi. The dot already went wrong. Hold on. 2. Okay.
0.
Okay. This is very interesting.
2.
Okay. This dot plot's gonna be fun. Keep going.
1.
Okay.
1.
Okay.
3.
Okay. I'm doing my best to line these
4.
up. Okay.
2. 2.
Okay.
3.
Okay.
4.
Okay.
3.
Uh-huh.
6.
Okay.
0. 3. 2. 1. 2.
Oh boy.
3. 1.
Okay.
2.
Okay. So now I'm going to count the dots. Thank you, Jovi. 1, 2, 6,
You're welcome.
7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So, and they said, they didn't tell me how many. 4, 5, 6, 7, 21. Okay, so see guys, sometimes 6th grade math is just counting. Okay, so we've got 21 dots on our plot. So now we can go ahead and answer some questions based on this. How many students made at least one phone call to a first cousin? What's the answer to that? Nicholas Abram says it's 21. Is that true? How many students made at least one phone call? Mr. Maddox disagrees. Leo disagrees. You know what, Nicholas, at first when I read that, I thought you were completely right. But it's that at least one. I forgot we had a 0, didn't we? So these two right here didn't count. So we had a 0 on our number line. So instead it's going to be 19. Okay, so because that would be at least one or more. Okay, and then let me go ahead and move this because I can't see because Zoom is in the way here. It says find the mean, median, mode, and range. I'm not going to find all of those because we have to move on. But what about the range? Because they ask for this a lot based on line plots. What would the range be? I'm going to call on someone for the answer to this. What is the range of the data set? I'm going to call on Leo. Hey, Leo, you didn't know you were being called on, but you are. You there? Leo? I think Leo might have pieced out. Okay, I scared him. I scared him away, guys. Raise your hand if you want to be called.
Can you guys hear me?
Oh, now I can hear you. I can hear you. You're there. Okay, what would be the range, Leo?
I'm pretty sure it's 6.
You are correct. And that would be because it's 6 minus 0, the maximum minus the minimum. And you get the answer of 6. So excellent job there. What would, Maddox, what would be the mode here? Mode. Maddox, you with me?
The mode is basically all the numbers added together, then divided by how many numbers are in the plot line, right?
Well, no, that's the mean. The mode occurs the most.
Oh, then that would be 2.
Excellent. So the mode would be 2 because it occurs the most, and 2 would also be our William peak because that's our peak of our plot. Will's never going to live this down. Okay, so Thank you for Leo and Maddox for helping me with that one. So now that I started talking about the shape of the data, let's just jump right into it. So describing the distribution of data. Sometimes you're going to be asked to describe. You guys love when you have to put words into your math, don't you? Describe the distribution. This is data can be distributed or spread out in different ways. So the great thing about math is when you do have to describe something, usually math will give you a bunch of things to choose from. And here is definitely the case, okay? So we're gonna learn a few different ways of describing, and then I'm basically gonna create a little word bank of things that you can choose to use when you're describing it, okay? So describe the shape of data of a distribution. Data that are evenly distributed between the left and the right side is a symmetric. Symmetry, symmetrical distribution, okay? Like a beautiful butterfly is symmetrical, okay? Because that means you could fold it and it would match up, okay? So it's like a mirror image down the middle, okay, as that line of symmetry. So if it's the same on the left and the right, it's symmetric. The distribution shown has a cluster, has several data values within. So over here, we have a cluster from 10 to 12. That's a cluster, okay, which is like a little group that's all clustered together. You guys remember when you were allowed to cluster together as humans? We can't do that right now. We are not clustering, okay? And then gaps. We have a couple gaps in our data over here. That would be just areas where there's nothing at all. And that would be a gap at 9 and a gap at 13. Okay, so you see how these words, you kind of already know what they mean, but now we're using them in a different way. And then of course the peak of this data over here would be 10, which is also the mode because it's the most frequently occurring value. Okay, so let's kind of delve a little deeper into that. Here's another example of they took answers to heights of, I'm guessing, humans, and they went ahead and plotted them in a dot plot. We have a gap right here, so you would say there's a gap at 65 and 66, and the peak of the data is at 70, and there's a cluster between 68 and 72. So those are all ways to describe the data, okay? Are there gaps? Is there a peak? Is there a cluster? So these are different things that you can describe. Now, sometimes there might be two peaks that are really way higher than the others. That's okay. There might be a few clusters, okay, and that's okay too. Now, we're not just looking at line plots. We're also looking at histograms, which we're going to learn more about next week. But right now, we're just looking at them to find their gaps and to find their clusters and to find the peaks, okay? And to find the shape of them. So let's just talk about gaps. A gap is a space on the distribution between data points without any data. So we have a gap right here. Oh, I forgot to copy and paste this. I really want another gap sign. I'm gonna have to let it go. Okay, so there's a gap between 30 and 60 here in this histogram. Here we have a gap between 32 and, well, let me look closer here, guys. It looks like 33 and 37, 38, 33 and 38. And then here we have a gap at 85. So we have 3 gaps here, and that's kind of common sense a little bit, okay? So just looking for that gap, that's one way of describing a distribution. A cluster, okay? A gathering. Remember, a cluster and a gathering, things that we cannot do right now, okay? In your data set, the data that wants to clump together, that's a cluster when it seems gathered together around a particular value. Like this number 8 seems special because everyone wants to be around number 8. So this is kind of clustered around the number 8. That's one way of describing it. Or down here, you might say there's a cluster around 2, or you could say there's a cluster between 0 and 6. Okay, so there's different ways of saying that. Okay, so clusters are when you have like a grouping around each other. Then we have peaks. A peak is a data point that is taller than the surrounding data point. It's like a spike in the data. Okay, so here we have a peak, and this looks to be about 13, that there's a peak there, 12-ish, actually, I think 12. A peak at 12, and then it kind of tapers down. William Peak's pretty tall there, okay. And then we also have a peak here over on our histogram. The peak would be the range of 20 to 39. That would be the peak right there. And then there's a peak over here, and that would be the peak at 3. And then there's also a gap, isn't there? Okay, so there's a gap on this one as well, and a gap here, but this is called something else, and we're going to learn what that little dot that's far away from the others is called in just a second. Okay, so clusters, gaps, and peaks. Those are one way of describing data, the distribution, the spread of data. Okay, it's very visual. Now, another way of describing it is how it's the real shape of it. So it's almost as if you are drawing an outline of it like this, okay? So these two data sets are considered skewed to the left. Now, when I first learned this, I thought that this was maybe skewed to the right, because I thought, well, it looks like all my data is on the right. Why is this called skewed to the left? So you need to think of the slide as the skew, okay? So almost like a ski, I don't even know what a ski thing is called, a ski jump, a ski, whatever, I don't know. Notice I've never skied in my life. But down here, you're like skiing down the hill. That's the skew. So this is skewed to the left. Now, another way of talking about this is saying that it's got a tail that's to the left, okay? So this would be like left-tailed, all right? And that would be because it kind of, here's like the body, and then you've got this, it's kind of like going out, the tail is going towards the left. So you could call this skewed to the left, or you could call this data left-tailed, okay? And you'll see more about this in just a second, because this is the other option. This is beautiful symmetric data, okay? So this is symmetric. So that means that even though this one is over to the right a little bit, it's still symmetric. That means that I can go ahead and draw a line here, and it's pretty much symmetric. Now, you could even say something is mostly symmetric, okay? So it doesn't have to be perfectly to be able to use symmetric as a descriptive word. And then I do want to go ahead and point out that data can be like this too, where there's like a lot of data on the right and the left, and then a little bit of data like this. So it could be symmetrical, but going downward as well. Okay, so it doesn't have to have a mountain shape. It could have like a ravine that looks like a V shape as well. Those are both symmetrical. Okay, so that would be ways of describing the data. And they go as far as to say, oh, and there's no gap in the data. So you can use both these clusters, gaps, peaks, as well as if it's symmetric or skewed left and right, okay? So you could use all of that. Let's move on and see one that's skewed right. So this is a ramp to the right, okay? And Maddox said it's kind of like a skateboard ramp, right? So this is skewed right, or it's sometimes called right-tailed. And I'll show you about the tail in a second, but it's kind of like, here's the body of it, and then the tail is to the right where it gets lower, okay? And that really is showing that this number 100, that data point, is skewing all of your data. It's pulling it all to the right. It's saying, come this way, when really most of the answers to this question, whatever it may be, maybe it's quiz scores, most of them are in the 60 to 85 range. And this 100, this one person that scored 100 is really skewing your data. So it's kind of dragging it over. So you wouldn't really want to use the, you wouldn't really want to average this data, because that 100 is going to make it seem higher than it actually is, because that one kid got 100, but really most of the people scored between 60 and 85. Okay, so that's skewing it towards the right, or it's called right-tailed. So don't look at the number of dots and think, oh, that's skewed to the left. Look at it more like a ramp, and it's going towards the right. It's sliding right. Okay. Now, let's look at box and whisker plots. These can be skewed left, right, or symmetric. And you guys saw this the other day. And when you were doing your box and whisker drag and drop activity, it was freaking you guys out a little bit because you're like thinking that they all have to be symmetric and look like this one in the middle, but they don't, okay? So this one over here is skewed to the left because most of the data is over here on the right, but then you've got this tail that's skewing it to the left. And I put my little lizard tail. This would be called left-tailed because you've got your meat and potatoes, okay? The most of it is to the right, but then you've got this left skew where it's being pulled toward the left-hand side. So sometimes like on Khan Academy, they call that left-tailed, but a lot of places you'll see that that's called skewed to the left, okay? And then this, where you have most of your data on the left, but then it's being pulled towards the right, this would be called skewed to the right, okay? Skew means it's getting like messed up a little bit. It's getting pulled to the right. This would be called right-tailed, okay? So here's my little right-tailed lizard. Here's my little left-tailed lizard. This is beautiful symmetric data. Okay, when your box and whisker plots look like that, you could fold them in half and they pretty much look the same. Now, they don't have to be perfectly symmetric. It could be a little bit longer on one side, but if you want to use that word symmetric, it needs to be mostly look like it's almost like a mirror image of each other. Okay, now this slide is included on your study guide. So make sure that you use that and that will help you out a lot, okay? And speaking of what we learned last time in these box and whisker plots, we looked at these images last time with the quarters because we were talking about quartiles. And looking back, this would be a box and whisker plot that was skewed to the left. That means most of the data was over here to the right, okay? But then you've got this 25% of the data is skewing to the left. Okay, it's getting pulled to the left. It's left-tailed, okay? Now, I want you to remember, no matter if it looks symmetric or if it's left-tailed or right-tailed, left-skewed or right-skewed, each piece of the box plot is still worth 25%. So we've got 25, 25, 25, 25. Each whisker is 25% and each part of the box is 25%, no matter how long it is or short. Same thing with the right-tailed box and whisker plot. So this is right-tailed. That means most of the data is on the left, but you've got this tail that's skewing it to the right, okay? And this is still going to be 25, 25, 25, and 25, okay? So you've got 75% of the data is over here on the left, but this last 25% is skewing it to the right, okay? So that's another way of kind of looking at it. Now, let's do some guided practice. In fact, actually, my mention of outliers disappeared. So I'm going to go ahead and pull up my study guide because I know it's on there. So let me show you how to pull up your study guide. So over here, I made this clickable. So you hit Control click and it should pull up for you. So I'm going to go down to where I have the outliers because I know it's here. I must have forgot to add the slide about it. And this just shows you another version of it. This is skewed left, symmetric, skewed right, outliers. Now, outliers. Oh, let me make sure you see this. Sorry about that. All right. So outliers. Whenever I say that word, I want tumbleweeds to just come across the screen. I'm going to have to do that later, like post edit or something like that, like a real YouTuber. But outliers are lying on the outskirts of the town. Okay. It's like, you know, the Grinch who stole Christmas, right? He's an outlier for sure. Okay. So he's on the outside of the town when you've got all the Who's in Whoville living right here in Whoville, and then you've got the Grinch up on the mountain just away from society. He's an outlier, okay? So an outlier is a value that lies outside. It's way smaller or way larger than most of the data, okay? And outliers definitely skew things. And in data and in science and business, we sometimes throw outliers away. outliers sometimes get thrown away because they skew your data so much that you don't want them included. So sometimes people will make a box and whisker plot and then they'll put an outlier on the outside of it because they don't want their box and whisker plot to have this crazy long whisker that goes to the outlier just because there was one outlier. Okay, so he's kind of like the odd man out, your outlier. And there were some things, let me see if there's any here that were outliers. Okay, so let's look at this guy here. This is an outlier at like 73, and then this is an outlier at 17 because most of the data is in the center here. Now, whenever I teach about outliers, sometimes kids all of a sudden just like start pointing at everything and saying, outlier, I see you, you're an outlier. Not everything is an outlier. If it's kind of close, but just on the edge of the data, or if it's just a whisker in a box plot, that's not going to be an outlier. An outlier, there's actually a formula to find an outlier. It's basically 150% of the IQR, the interquartile range. We blow it up and we expand out the interquartile range 150%, and we say those are the fence posts. Those are the lines that if you cross that line, you're an outlier. If you don't cross that line, you're good. Okay, so there is this like actual formula that you can use to determine outliers, but usually you guys are pretty good about spotting them. You'll see them, and the ones that I'm going to be putting on your quiz with distance learning and stuff are not going to be crazy hard ones. But if I were in regular class with you, I definitely probably would teach you that outlier formula. It's just very complicated and would be really frustrating for you and I to learn that. So this outlier would be your maximum, but it's also an outlier, so you might want to throw it away. So the scientist or the business person or whoever, the market researcher, they can decide, you know what, I'm going to throw that outlier away, and then I'm going to have it maybe do a line plot with the outlier and then a line plot without the outlier. Or they might in their research say, this is without the outliers that were at this and this, okay? So there's different ways to go around it, but an outlier is pretty straightforward. Some math teachers like to say outlier, like, I don't know, you're an outlier, but I think of it like an outcast, okay? We're gonna do some guided practice now, and this is really important because these are the ones that are similar to questions you'll find on a quiz, so please try not to leave during guided practice. There's things I still have to go over about Friday's routine, so don't just ditch, okay? Stay with me. It won't be very much longer, but I want to make sure this is extremely important information you need to get for your quiz. All right, so Zaylen surveyed his classmates about the number of pets they had in their homes. He displayed the results in this dot plot. How many people did Zaylen survey? I told you that would come up. Well, you're just counting the dots. Okay, so how many? It's not going to be, oh, they surveyed 9. No, that's the number of pets, and someone answered 9. So just be careful about, you know, just looking at the plot and just making a quick decision. You're going to count up the number of dots. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, I got 24. Some people, yeah, 24. Okay, so this would be 24. See, a lot of statistics is just plain old counting, guys. And sometimes you got to count twice because sometimes just the counting is kind of like complicated, you know, because we haven't done that something so simple in our lives lately. We've been doing too much complicated math. Okay, so describe the shape of the data distribution. How is it spread out? Go ahead and chat me what you would say. There's several answers what you could do with this. We talked about gaps, clusters, peaks. We talked about skewing left, skewing right. We talked about symmetrical data. What would you say to describe this plot? And like I said, there's lots of different ways to describe it. And I might call on you. So give me an answer. What would you say? And maybe all together we can kind of formulate a good response. Okay. Let's go ahead with Miss Murdoch. Hello, Kate.
Hi.
Hi. So I've got, I saw your answer. Can you go ahead and tell everyone what you thought?
I said like right tail or skewed to the right?
Yeah,
Because
it's
all the
skewed to the right or right-tailed because it's got that tail to the right. It's got that drag. It's kind of being pulled to the right a little bit. So that was a great way of describing it. And then I'm going to go ahead and call on a couple other people to kind of add to that answer. Let's see. Who said that really good thing here? Nicholas Abrams. I'm going to call on you. If you guys raise your hand, it's so much easier for me to call on you. Okay. Thank you, Nicholas, for raising your hand. Then you go to the top of the list. Hey, Nick,
Hello.
what were you saying?
I said 1 through 4 is a cluster, 1
Yeah.
is a peak, and then 6 may be an outlier because 8 and 9 are on the side right there next to each other, but 6 is just sitting there in the middle by itself.
Okay, I'm glad you brought that up. Let me write this down. So one is a peak, 1 to 4 is a cluster. So you could make this in sentence format. You know, there's a peak at 1, there's a cluster from 1 to 4. The total data is skewed right. Okay, so you can make all this into sentence format, but I know you guys know how to create sentences. I'm not going to do that. Now, you mentioned outlier and you said this guy's kind of hanging out by himself. Well, he's creating gaps is what he's doing. So you could actually say there's a gap at 5 and a gap at 7, but you can't have an outlier in the middle of your data. So the outlier would have to be like way over here or way over here. And since there's 2 at 8, 1 at 8, 1 at 9, you're really not going to call those outliers. But if 9 was maybe by himself, then he would be an outlier, if that makes any sense. So I wouldn't say there's an
know what
outlier.
you would call it if a 6 was in the middle, so I said might instead of it is.
Yeah, that was a
I
good
know
guess. And really just him being there is creating a gap at 5 and a gap at 7. So those are all great ways to describe that. I'm going to go ahead and let's look at a couple other guided practice questions. So let's look at this. The more questions you guys see, the better you're going to get at this, okay? The dot plot shows the number of minutes it took Greg to get to work each morning for the last 27 days. Now that's important because it just told me there's 27 dots. Okay, so now I don't have to count them. Yay. Now select all the statements that are true. You know they love putting that in there, right? So it's not multiple choice, it's like multi-select. On about half the mornings, it took Greg longer than 57 minutes to get to work. So I'm going to go to 57. And they're saying that about half the data is on the left and about half the data is on the right. Well, it's definitely not symmetric, but yes, I would say about half the data is on the left and about half the data is on the right. So that is actually true. Now, the greatest amount of time it took Greg to get to work was 60 minutes. Was that the greatest amount of time it took him to get to work? No, because this is the greatest amount of time it took him to get to work, 62. So it wouldn't be 59 either. That's the peak, but that doesn't mean, that just means that answer, that happened the most, okay? It was the most frequent. This was the greatest amount of time, this 62. So that is not true. The amount of time it took Greg to get to work that occurred most frequently was 59. I just said that. So the mode or the peak is at 59. So that is true. So C is correct. And then the times it took Greg to get to work were evenly distributed between 52 and 62. 52 and 62, are they evenly distributed? No way, they're not. There's a whole lot of numbers over here. These are not, I would not say at all because of that 59, they're not evenly distributed. The least amount of time it took Greg to get to work was 52 minutes. That is correct. Now, some kids will look at this and they'll say, no, there's 3 of them there. It can't be 52, Miss Melanie. It was 53 and 56 because they only had 1. No, they're not asking what was the least frequent answer. They're asking what was the least amount of time it took him. And that we see here that this is showing time. Okay, so it's 52. And so those are the 3 that are correct for that one. All right, we're almost done, guys. So let's just look at this. I want to, sometimes they give you 2 dot plots or 2 things to look at, and you have to compare. So this is the Hawks and the Eagles, and these are runs scored. It says which team's data is more symmetric? They're not perfect, but which one is more symmetric, would you say? The Hawks or the Eagles? Go ahead and shout out to me what you think, and I'm going to call you out. The Hawks is correct. So good job to the birthday girl. Good job, Owen. Good job, Kelsey. Good job, Cooper and Kate. Great job. So the Hawks is more symmetric because it's kind of like almost like trapezoid shaped, right? Which is a symmetrical shape. Now, which team has a peak at 3? That would be the Eagles, obviously, right? Which team has a larger range? Okay, so remember to find the range, you look at the highest number, not the highest number on the number line, because there's no 10s as answered on the number line. That's just there as a measurement. So not 10, but we look at 7 minus 1, because those are the maximum and the minimum. You get 6. So the range for the Hawks is 6. Whereas this is 10 minus 3, and you get 7 for the Eagles. So the team with the larger range is the Eagles. So that's how you find range. You're subtracting your maximum minus your minimum, okay? Number 4 says, which team has had more games that ended with scores of 5 or more? So we're just looking at this. Which one had more games that scored 5 or more? And that's definitely the Eagles, because it has more dots that are, to the right side of the 5. Okay, because these are all representing game scores. 1, 2, 3, 4, 5, 6, 7, where this one had 4. Okay, which team's dot plot has a gap? Which one has a gap? Remember, a gap is like a little valley. So this one definitely has a gap right here at 4. So the Eagles have a gap. So that's not really that bad, is it, guys? Okay, so 1 second, I want to update my chat. Yeah, you guys are doing good. This one does not really have a gap because this is a little dip, I would say, but not really a gap. Okay, but I'm glad someone brought that up. All right, so these are just different ways of I want to throw this out there and see if you want to raise your hand to describe whichever one of these you want. I'm going to call on you and see if you can maybe describe it. I gave you a word bank. So here's gap, cluster, peak, outlier, skewed left or left-tailed, skewed right or right-tailed, symmetric, and you can choose any of these you want to describe. So raise your hand if you are interested in doing that. I'm going to choose Martin Hodges. Hey, Martin.
Hi.
Could you describe one of these?
Describe which one?
Any one you want. Whichever
Okay.
one you think you know what you're doing on how to describe, and the word bank is right over here. You can use any of those words.
Okay. The temperature one, there's a gap in between 29 and 23.
Yes.
And 29 is the outlier.
Oh, perfect. Exactly.
23 is the peak, and it's skewing to the left.
Oh my gosh, that is amazing. I couldn't have done any better than that. That is awesome. Yes. So it's skewing to the left because it's left-tailed. It's like a slide going to the left. Here we got an outlier. We've got a gap. So these people might want to throw out the outlier, and then that would remove the gap, and then that would kind of say something more about this data. Awesome job, Martin.
It's clustered at
Yeah.
21 and 23.
Excellent. Perfect. Yeah. You said everything there is to say about that. That is awesome. Great job. Okay. Anyone else want to try a different one? Because man, Martin knocked that out of the park. So he said it all about the temperatures. So raise your hand if you want to describe a different display. I'm going to choose Maddox. You there?
Yes, I'm here.
Okay, so which one do you want to describe?
I guess I'll do passes thrown.
Okay. What do you want to say about that?
So there are no gaps, as I can see from the data chart.
Very good.
I could say, well, basically the whole entire, I guess, I don't know how to say this, but it's all kind of pushed together. So basically the entire data is a cluster.
Yeah, that's true.
The peak is at the frequency 15 and 30 through 39.
Yes.
Past. There are no outliers.
Right.
It's symmetrical.
Yes, very important. That's the most important thing about that. It's definitely symmetrical with a clear peak. And if you want to talk about the clustered, but it is kind of like clustered all around 30 to 39. So that's a good point. So now we kind of have to stop because we got to keep it moving here. So I'm going to go ahead and just say one more thing. So do not leave yet. What I need to say is, and of course you can rate yourselves how you feel about that skill. You guys really did, I think, an amazing job at it. But Friday, this is the important stuff right here. New Friday routine. So I am following the exact Friday routine that Mr. Wolford wants us to follow, and it's been communicated to your parents, and that is quizzes are going to be Fridays from 11 to 2. So you cannot sleep in on Friday till 3 p.m. and then take my quiz at like 11 p.m. Okay, you have to take it between the window of 11 a.m. and 2 p.m. So all that like lunchtime area, you're going to be taking the quiz. So on Friday morning, you want to go on to Edsby and look at the journal post, and you can do one or two things. From 9 a.m. to 11 a.m., I will be having an open Zoom review session, a Q&A session. Okay, all the teachers are going to have office hours from 9 a.m. to 11 a.m. on Fridays from now on. Mine, I'm making a Q&A and a Zoom review so that we can review for the quiz that you are just going to take right after that. Now, since it's a 2-hour window of time, I'm not going to just answer questions for 2 hours. So part of it, we're going to have a Q&A, and then the other part of it, we're going to do a GIM kit, because that's a fun way of reviewing right before your quiz. So if you want to join us, we'll probably do the Q&A at 9 and then the GIM kit at 10 or ish, you know. And then if someone has a question at the end, we'll stop the GIM kit and then go ahead and move to the quiz session. The quiz session is mandatory. So the review is optional. The quiz session is mandatory. And the directions on how to get to the Socrative quiz will be all up on Edsby in the journal section. And that's how you're going to do it. Okay. So remember, there are no retakes. No retake. Someone just said I thought we had no Zoom Friday anymore. No, you have no lessons Friday anymore. And I'm not requiring you to go to Zoom. Zoom review is completely optional. Okay. It's me that is required to open it up for you guys. Okay. And Friday you do have school. It is a school day, and that's the day that you're turning things in, and that's the day that you are taking quizzes. Okay. From here on out. Now, one thing, no retakes on the quizzes. Some people tried to squish in last time and like take it again and stuff. No. I only allowed that on the first like Fibonacci one because I needed you to know about the rubric really well. But now it's like a legit quiz, guys. Okay, and I'm not there to like have a quiz session. It's open internet. Okay, that's what I call it. You've got a study guide. You can use calculators, but you can only take it once. So take your time and take it during that 11 to 2 period. Okay, so don't show up at 1:55. Okay, try to give yourself enough time. And today, remember, on your own, you're doing the IXL for practice, and you are looking over the study guide. If you have print or ink, print it. If not, pull it up as a PDF. But remember to show up on Friday for your quiz. Okay, if you need to ask me any questions, I am available from 2 to 3 today. Thank you for staying. I know it was long today. We had some internet issues and a lot to get through. Thanks so much. I will see you on Friday. Peace out.